Okay, just getting set up real quick, then we will start the stream. Okay, just give me a few seconds. Okay, it looks like everything's working. We will post the link. Okay, cool. So now that that link has been posted, let's get started. Okay, cool. So I'm going to be continuing working on Phalanx, and I will be doing what I was doing yesterday with trying to actually let me close this tab. Okay, cool. Yeah. So I'm just gonna throw Phalanx against a few more GitHub projects to see if it finds bugs, because I want to find bugs with this bug finding tool to lend more credibility to the sorry, one of my friends just sent me a joke. Yeah. One of my friends, yeah, getting back to the point, lend more credibility that it can actually do what it's intended to, so let's find a few more projects. So far, Phalanx has found bugs in like 10 different GitHub projects. I'd like to get a few more before I move on to the next stage of verification for this tool. Most of the GitHub projects that it runs against are fairly small. I want to run it against massive code bases with known vulnerabilities, so I can effectively just test and see that does it find the vulnerability. With that, that will be fun, but that will be after what we're doing right now. So let's get at it. Actually, okay, nothing in the chat. CP server. Okay, I'm going to be looking for some HTTP servers. HTTP, the protocol has a lot of variable length and like text-based functionality, which a lot of the time will yield. It's easier to write bugs than compared to like a protocol that has like a fixed length. Every packet is exactly the same size. See this HTTP server right here? I'm just gonna make sure that I didn't already work with that. Nope, different one. Okay, cool. Let's see. Okay, let's try this. Let's clone the repo. Okay, we clone the repo. Let's compile it. Okay, it compiled, cool. I'm just gonna check if I can run it real quick. Okay, it looks like it can actually run, it just needs directory, or, sorry, yeah, path. Okay, also needs a port. I'm gonna run it on port, let's see, 8080. Okay, so we can actually run it. Okay, cool. Now let's run it against Phalanx, or run Phalanx against it and see what it finds. Okay, run the headless analyzer, path to the project name, I'm just going to call this HTTP. we're going to be importing this binary, and it will be from here. And we're going to be running the Phalanx script after it's done running, or after it's done processing and analyzing the binary. So let's just give it a second to run. Okay, cool. So it flagged 3 different sprintf calls with a %s, so it's using a %s in the format string for sprintf, and it flagged a stir cat. So let's actually at this point look at the binary in Ghidra. Need to remove that. There's already a binary in here named the same thing. Yeah, let's analyze this. And okay, these are the 4 calls. I'm just going to start looking at them from this sprintf, then that one, then that one, then that one. So Nazem asked a question. Let me answer it now. Do you plan to stream other content? Yes, I do plan on streaming other content. Yeah, to answer your question, Nazem, I do plan on streaming other content. The content that I'm going to be streaming is primarily based on like what my current project is. At least for the next like week or two, my current project is probably going to be continuing developing the static analysis tool. But after that, I'll move on to another project, in which case the topic will change to whatever that project is. If you want, feel free to suggest something. I was actually kind of wanting to start to get into more kernel exploitation, so feel free. And I'm just going to type out that response too. Okay, cool. Now let's get back to this. Sprintf. Okay, the sprintf, the %s that's being written is a static string, so I don't care about that. We have no influence over the data being written with this %s. Let's try this one. Same instance, %s that's being written there. However, this sprintf right here at 1CAD, which is the sprintf flag right there, local 4F0 is being written with a %s to local 468. Let's just see if this is misclicked. No. Destination, let's see, is destination a stack? Yeah, it is a stack buffer. So if you control local 4F0, depending on how much control over this might be a stack buffer overflow right there. So let's Okay. Yeah, just responding to a message in the chat. Someone was asking about doing kernel exploitation, and I was kind of thinking that was one of the projects that's on like the to-do list because I want to get more into it since I don't have a ton of experience with that. But I might move it further up the to-do list to be determined. But first, let's finish this. Okay, cool. So what is happening? This sprintf call right here, I just want to see this local for f0. Do we control the value? We could try looking at it statically to figure it out, but I think dynamically, at least just for trying it out first, will be a bit easier. Actually, let's do that. I'm going to set a breakpoint for sprintf call. Oh, there we go. We're going to be running on port 8080, and this is going to be the web directory. And let's send a request to the web server and see if the breakpoint gets hit. Okay, isn't saying server error accepting connection invalid argument. Maybe it's expecting us to actually reference a valid file. No, that is not the issue. Let's look in Ghidra. It's outputting invalid argument. Let's see where that string is coming from. Likely, there's a check that's like, if this condition isn't true, then print out this string, so we can just easily check to see what is going wrong here. Okay, it looks like this right here, server error accepting connection. Let's see, where is this reference? Where accept? Okay, for some reason when it tries to call accept, it's not. It looks like that's the issue. What exactly is causing that, I'm not sure. Let me try running on a different port. Permission denied. 8,000. Okay, so this is not unable to open directory. Error accepting connection. Okay, cool. So for some reason it's not able to call accept. Not sure why, so I'm just gonna move on to another GitHub project. No makefile. Yeah, I don't want to deal with that. Okay, this is written for Windows, so don't want to deal with that. tiny HTTPD. Did we already work with this one? I'm just gonna check. This is the list of GitHub projects that just name that I've already like verified that Phalanx found a bug in. Not seeing tiny HTTPD, so let's give this one a shot. Oh wait, no, wrong directory. Okay, that cannot compile, so not dealing with that one. Source. Okay, this one looks like it might be fun to work with. Let's try this. Can we compile it? We can compile it, cool. Let's try throwing Phalanx against it to see what it sees. Give it a second for the bug finder to work. Okay, it's flagging a lot of different things. I'm gonna go ahead and throw it in Ghidra so we can look at what it's flagging. Okay, let's start with this memmove flag. Input buffer. Okay, it looks like it's... So what it's looking like right here is param1 is a struct which has offsets param1 plus ox138 is buffer of some sort. I'm guessing it's from the heap because typically structs like this pointers are allocated dynamically thus from the heap. So I'm just going to keep looking to see if there's a more, at least at first glance, more interesting like mem copy or star copy, something like that. And where's n coming from? Okay, let's look at this star copy, param3. What does this function do? I'm curious. Okay, cool. Let's continue looking through. Here's another stir copy. So do while does not equal to 0, star copy there. Where is this value being used? I'll be right back. I'm going to quickly use the restroom. Okay, I'm back. Yeah, I had a little bit too much coffee. Okay, cool. So we're looking at the store copy. You see here that this destination, I'm just going to call it dest. Ghidra is not changing the variable names. I just want, where is PC var 11 referenced in this do, or this, okay, so this is the do while loop I initially misread. I thought this entire thing was in a while loop. PC var 11, where is it referenced? If I can see where it's referenced, that should give me a good idea as to what it is, but I'm not seeing anything clearly stick out. I'm just gonna quickly run through the rest of these checks and just see if there's anything that really pops out as interesting. Invites. Okay, nothing there. Nothing there. Yeah, the let me just go ahead and explain like why n bytes. So in order to actually verify if this is a bug or not, what I'd probably start off by doing is see if first off, can I hit this read call dynamically in a debugger? Cool, I can. Is the destination, what region of memory is it being scanned into? And if it's from the heap, try to trace where the malloc call that it's coming from is in the size and correlate that to the size of n bytes. Which, speaking of which, where is n bytes coming from? It's coming from right here, so it's coming from somewhere in the struct itself. Actually, it's some value minus lvar6, which comes from there. Okay, so the value looks like it's effectively coming from the struct. So, not 100% interesting. UVAR14, yeah. Just gonna scroll down and see this one right here. Okay, cool. So, actually trying to like figure out if these, due to how like the code base is, if these are bugs or not, would take a little bit of time. So I'm gonna just move on to another project here. Okay, let's try something else. UHTTP, we did that already. HT serves, sure, let's do this. Okay, we can compile and it looks like we can also run it, so let's throw a Phalanx against it. Give it a second to run. Only flagged one thing, the receive call. Let's take a look at it. Probably should have imported it into Ghidra as a waited for Phalanx to run. and that receive call happens at this address. What are the arguments to receive? Second argument is the destination buffer. Third argument is the size. So in this case, this is the destination. Okay, now I properly labeled it, and this is the size. Size equals OX400, and the space it's being scanned into is where local 848. 1024, that's OX400. Yep, just double checking. Now, you can see it's set here to OX400. Is there anywhere in here that, where else does it get written to? Because we might be able to do some, or just reassign the value of it. So, for this, let's just see where size. So size is written to here. It effectively has return value for receive. I'm pretty sure is the number of bytes read, and we can see here that it is set equal to size minus the amount of bytes read. Reassigned there. Size equals as for a 10 break. Okay, cool. So what I'm going to try and see is if it's possible is effectively what I'm going to see if might be a bug is an int overflow. So if this size, I'm not seeing a check if this size is like less than 0 or anything, or any real size check on it. Actually, first I'll let me back off. What idea behind decrementing size is, so this buffer is only like OX400 bytes long, and the size just gets decremented in correlation to the amount of bytes scanned in. Now, what might be able to happen is you might be able to subtract more from it than what's actual. Might not be able to do it, but potentially what we might be able to do, subtract a value from size greater than size, and then it will do an underflow back up to OXFFFFFF, since that's negative, or just a really large number, since negative numbers, when interpreted as signed integers, are fairly large. So, and we look at receive size of t. I'm pretty sure the size of t, that data type, is unsigned. So we might be able to do something with that. Gserve. I want to set a breakpoint for this receive call. What port is it listening on, I wonder? It's listening on 8888. Okay, it's here. RSI, RDI. Wait. Where? Okay. RDX, this is the size argument right here, OX400, and let's see what happens. Call it repeatedly. Okay. Let's set a breakpoint for this sub instruction. pi break at 0x1848, continue there. Okay, so what's going on here? Um, in the debugger, it's multi-threaded, so it's having a little bit of a fun time going through it. I'm gonna move on to another project. Let's look for another one. Already did that one. UV HTTP. Okay, it's using outside libraries. I don't want to work with that. Okay, this looks like it might be fun to work with. So let's try it. Okay, we're able to compile it. Let's throw Phalanx at it, see what it comes up with. So let's type out the command for to run Phalanx import. Where are we importing it from? We're importing from here. And we need to specify the script now. Give it a second for it to run. As it's running, I'm just going to import it into the Ghidra project, or the GUI project, so I can actually look at it. Okay, so Phalanx crashed. So this is a good thing we found a flaw within Phalanx, and we can then fix it. Let's go ahead and analyze this. First, I just want to check these two flagged function calls and then fix the issue with Phalanx. But yeah, this is the reason why I go ahead and do this type of testing with tools that I make, because a lot of times it's pretty hard to find the bugs that will cause crashes, so you can go ahead and do this to find them. R1. Okay, this is just a variable receive call. It's scanning in a variable amount into a pointer from some structure. And let's take a look at this. Okay, read FD wrap. Okay, it looks like it's scanning into another malloc space if I had to guess, but I could be wrong. The reason why I say malloc is because the destination pointer is coming from a struct, and typically from what I've seen, that is indicative that that space is from the heap. So let's go ahead and fix this problem now that we're seeing. Line 527 on Phalanx. Let's go ahead and look at that. What's going on here? Oh, okay. So it's looking at the inputs to AP code, which is being returned as a var note array, and it's effectively just trying to access an index past the end of it. So what we can go ahead and do is we can just go ahead and add a check in here to effectively just check for that condition. How do I do this? If inputs dot length is if an array has a length of 3, the max index that I can reach is 2, and we index them off of a 0. So minus 1 is less than destination arg. And so why am I doing this? The argument that we are passing as the index is either destination arg plus 1 or size arg plus 1. Why is that relevant? So that's relevant because, well, the initial plus 1 was because, well, minus 1 was because if the length is 3, the max argument is 2, and we're adding another 1 to it, so we need to decrement it in order to account for that. So, and if that is there, you just return. Let's see if running, oh, that check will fix the problem. You already imported it, so we just need to process it now. Okay, so that did actually fix that check right there did actually fix the problem. Okay, cool. So this stream has been going on for 40 minutes, so I'm going to go ahead and end it here. Unfortunately, didn't find any cool stuff, but oh well, that happens in this type of work. Thank you for watching, and see you later.